Good day, everyone. I am Catherine Vedano from Bachelor of Secondary Education, major in English. So my topic that is being discussed today is about percentage distribution. So I have here the target objectives that are given, discuss the terms, use, and formula of percentage distribution on evaluating data gathered. Justify the use of percentage distribution in statistical treatment while conducting research. Then, calculate percentage distribution using the formula given that can soon use on gathering and evaluating data in a quantitative data or research. So, percentage distribution is one of the statistical treatment used in gathering and organizing data collection in research. It simplifies complicated materials into a manner that is easier to comprehend. For instance, when a poll of 1,000 people are conducted regarding uh, their favorite fruits, the percentage distribution displays a proportion of respondents who enjoys each fruit rather than presenting all 100 responses. Presenting it as a 30% like apples and 25% like bananas, for example, makes it easier to quickly understand the key trends. If 300 likes apples, 250 like bananas, and so on. Moreover, it becomes such a great help for simple comparison of multiple groups or categories within the data. In research comparing male and female students' academic achievements in various disciplines, percentage distribution can reveal how many male and female students receive in an A, B, C, and etc. in each subject. This allows researchers to easily spot difference and similarities. So, in this lesson, we will dive further about the meaning and percentage distribution. And later on, I will going to teach you how can we able to compute or calculate percentage distribution. But first, let me share to you the definition or meaning of what is a percentage distribution. So it is a statistical tool that shows how a variable is divided into different categories or groups. So this techniques aids researchers in determining the relative frequency of various segments within a dataset, allowing for more effective data analysis and interpretation. So, statistic treatment of data is essential to make the use of data in the right form. Raw data collection is only one aspect of any experiment. The organization of data is equally important so that appropriate conclusion can be drawn. This is based on Kyla 2009. So it functions as a visual representation, assisting in understanding how values are assigned and providing insights into a pattern of trends in the acquired data. It is an allocation of selected studies based on the specific categories such as publication type or topic of study, represented in terms of the proportion or ratio of each category to the total number of studies. So we have here the process of creating a percentage frequency distribution. So we have here identifying the total number of observations to be presented. Then counting the total number of observation within each data point or grouping of data points. The next part would be dividing the number of observation within each data point or groupings of data points by the total number of observation. Then we have the sum of all the percentages corresponding to each data point or groupings of data points should be 100%. Then the final step of creating a percentage frequency distribution involves displaying the data. So it can be hard for us to analyze if we were just going to display it with words. So I'll have you prepare some scientific calculator or calculator on your cell phone, on your cell phones, so that you can calculate with me, so that we can learn further about calculating percentage frequency distribution. But before that, let me analyze to you, as I have prepared here some example. As a part of a study examining the relationship between number trips of a physician and socioeconomic status, one might survey 200 individuals about the number of trips each made to a physician over the past 12 months. The survey might ask each individual to choose from the following responses: 0 times during the past year, 1 to 3 times during the past year, and 4 to 6 times during the past year. Then 7 to 9 times during the past year, and 10 or more times during the past year. If the 10 respondents were to select the first response, 80 were to select the second, 50 were to select the third, 40 were to select the fourth, and 20 were to select the fifth. Then the percentage frequency distribution would be calculated by dividing the number of responses for every choice by the total number of responses. Or let's say it's 200 thing. So the percentage frequency of each would be 5%, 40%, 25%, 20%, and 10% respectively. So do you get my point? So if not, then it is the quick picture or illustration of what I've discussed earlier about the examples. So we have here a table of percentage frequency distribution, whereas the left is the representation of the response, then the right is the percentage of respondents selecting response. So the 0 times during the past year is the 5%. The 1 to 3 times during the past year is 40%. 4 to 6 times during the past year is 25%. 7 to 9 times during the year is 20%. Then the last one is the 10 or more times during the year is 10%. So if you don't get the first example, don't worry, because I got you. I prepared another example so that you can further understand how to calculate a percentage distribution. So I have here this sample situation. Okay, percentage frequency distribution could group the number of trips to the doctor into 3 distinct categories, such as 0 times, 1 to 6 times, and 7 more times. When the grouping the responses, the total percentage of each category of responses is merely the sum of the percentage of each responses. When grouped in this manner, the frequency percentage of 0 times would remain unchanged at 5%. The total from 1 to 6 times would be 65%. It is the sum of the 40% and the 25%. And the total 7 or more times would be 30%, which represents the sum of 20% and the 10%. So, as I've said earlier, I have here another example. So this is the formula, as you can see. P equals F divided by N times 100, where P stands for percentage, F stands for frequency of each group of respondents, and the sample size N. It is the sample size, which is the 100. So for example, let's say we conduct a survey of 200 students to find out their preferred mode of transportation to school. The results are as follows. So the bus, we have here the 80 students who wants bus as a mode of transportation. We have here 50 students who wants car as their mode of transportation. Then 40% for bike as their mode of transportation. And the last one, we have the walk as their mode of transportation. So for the bus category, the frequency number, which is the student who prefer the bus, is 80. Then the total number of observations is 200. So using the formula, the percentage is 80 divided by 200 times 100 is equals to 40%. For the car category, same solution. The frequency is 50. Then the total number of observation, 200. Then the percentage is 50 divided by 200 times 100 is 25%. So for the walk category, we have frequency of 30, then the total number of observation 200, then the percentage is 30 divided by 200 times 100 is 15%. Then the bike category, the frequency is 40, the total number of observation is 200, so 40 divided by 200 times 100 is 20%. So the computation would be here. We can present the percentage distribution in a table like this. For the bus, we have 40%, car 25%, bike 20%, walk 15% of a total of 100%. So the percentage distribution table clearly demonstrates the relative popularity of each method of transportation among the question respondents. So that's all for my simple report. I hope you catch something useful for your research, as you conduct your thesis. So I hope I can make things clear during my discussion. So thank you guys for watching. Have a nice day.